we have, doing different things. And then as we go throughout the chapter, we're going to talk about triangle congruency, and we're going to do some proofs of triangles and proving different things about triangles. All right, so look at the warm-up at the top of page 32. See if you can figure out angles 1 and angle 2. See what the measure of those two are going to be. Measure, yep. What is the measure of angle 1 and the measure of angle 2? Think about things that we've talked about throughout the year. It's a good thing to talk about because it's already going to be November on Saturday, and it means we're getting closer and closer to the final, which means we get to go back and remember all the things that we've been doing throughout the semester. Remember all the fun stuff we've been talking about. Okay. Shouldn't be a whole lot of work involved in these. The work should be pretty straightforward. Angle 1. Who wants to try angle 1? Hannah?
31 degrees.
Okay. How come?
Because it's on it's it's on the opposite side of
Okay.
the marked angle.
Anybody remember what the word for that is? Vertical angle, yep. So we can't do like alternate interior or corresponding because we don't have parallel lines. But basically what we talked about was if they make an X, right, then they are vertical and they are across from one another. They are congruent. So angle 1 is 31 because they are vertical angles. Okay, so that's good. Okay. Angle 2. Yeah.
Either side of those supplementary angles on top would be 90 degrees.
Okay.
So you're going to take 90 subtracting 31 to get angle 2, which
Perfect.
would be 59.
Okay. Good job. So we know this is 90 right next to it because they make a straight line. Okay. And so if the one side's 90, the other side's got to be 90. So these two together must make 90. So we say that they're complementary. So 90 minus 31 would be 59 degrees. So those are all things that are going to continue to come into play, right? Vertical angles, they're not disappearing. Vertical angles, we're going to see those all throughout the year. Complementary, supplementary, linear pair, all of those things are really, really important things that they just keep coming back up from time to time. And obviously we're going to see them on the final, but we'll even see them in second semester. And we're going to see them off and on throughout the entire year. So we got to remember some of those key things that we've talked about as we've gone throughout the year. All right, so starting off here, classifying triangles by sides. So when we're looking at sides, the first one is no sides are congruent. We have 3 sides. Every triangle has 3 sides. If no sides are the same, we call that a scalene triangle. So one of the first things we're going to do today is we're going to name a triangle. And we're going to name it by its sides, and we're going to name it by its angles. So first of all, we're going to focus on sides. If 2 sides, at least 2 sides, are the same, we call it an isosceles triangle. And if all 3 sides are the same, then we call it an equilateral triangle. Equals spelt a little bit different here. I know that the normal equal that we use is EQUAL. Here it's EQUIL. Lateral means side, right? So equal sides is all that's saying. So if you broke down the word from its prefixes and bases. Okay, angles. There's 4 different ways to classify a triangle by its angles. So now if we look at the inside of the triangle, if all three angles in the triangle are acute, then we just call it an acute triangle. If we have one right angle, we can't have more than one, because then I wouldn't have a triangle. But if we have one right angle and then the other two would be acute, so if you want to write that, you can. One right angle and two acute angles. Same thing here, if we have one obtuse angle, the other two would have to be acute. And then the last one, if all three angles are equal, then we say equiangular. Okay, what would be the measure of each of the angles if all three of them are equal?
The same.
Okay, and what would that measurement be? How many degrees do we have in a triangle total? 180. So 180 divided by 3 would be 60. So that means all of them have to be 60 degrees if it's equal angular. Okay, and here they don't necessarily give me, but once again, the markings, right? The markings are really, really important to everything that we do. Up here, sides are tick marks, right? We see the 3 tick marks, that means all 3 sides are the same. Here we have 2 sides that are the same. Here, none of the sides are marked, okay? Down here, we're marking angles. And so those markings are really, really important to identifying what we have. Okay, so here we're going to identify some triangles based on the information that's given or that we can try to prove. And so the first one that we're looking at is this one in the center of the figure. Okay, so what would we say here? Okay, do we have, if I look at the 3 angle measures, how many degrees are each one of those 3? Well, and what would be one of the first things that I notice?
They're all acute.
That they're all acute. Okay, so we could call it acute, but because do we have an obtuse angle here? No, they'd have to be bigger than 90, right? We don't have anything bigger than 90. They're all less than 90. Okay, 2 of them are the same. So if 2 of the angles are the same, here's the other thing that we can tell. And I think this is marked on the picture, but it's kind of hard to tell. But just for future reference, if 2 of the angles are the same, then the 2 sides opposite those 2 angles are also going to be the same. So if we have 2 angles the same, we also have to have 2 sides are the same. So that makes this what type of triangle? If we identify it by its sides. Isosceles. So this would be an acute isosceles triangle. Okay, we're naming it by its sides and its angles. So we have to have 2 words here. One sides and one represents angles. And as we want to try to do as specific as we can. We know it's not obtuse, there's no right angle, so we can kind of go process of elimination to what makes the best way to name it. Okay, the triangle that's used as a musical instrument, all 3 sides are marked the same. So we would say that this is equilateral. And if all 3 sides are the same, what do you suppose that means about the angles? They're also the same. Even though that's not marked, we can assume that to be true. If all 3 sides are the same, all 3 angles are the same, so we would say this is equiangular. Okay, and what I told you before is we want to use the most specific way to name this. Like some people would say acute on this one. Would acute be true? Are all three angles acute? Because what did we say the measure of each of these angles is going to be? 60. So are all three angles less than 90? Yeah. But what's more specific, equiangular or acute? Equiangular, right? Because acute just means they're some number less than 90. Equiangular means they're all equal, which means they're all 60. Okay? So equiangular would be better than acute in this case because it's more specific. Okay. Sometimes, and that's one of the things we've talked about with geometry, is it's really hard to determine based on the looks sometimes, right? Now, there's one thing here that we definitely know, and we know the two sides are the same. So if I was going to name this by its sides, what would we say? Isosceles, okay? Okay, the difficult part here is the angles, okay? And these two we know for sure are what? Would I say that this angle is bigger or smaller than 90? Smaller, right? It's definitely acute. What about this guy right here? Some people might say it kind of looks like it might be 90. Some people might say it's bigger than that. Like, it's hard to tell, right? And so if we have a problem like this, we'll try to make it obvious for you. But let me say that this one is, let's say that this is 100. And I'll tell you that that's 100. We don't really have any way of knowing that for sure. But if I tell you that it's 100, then what would we say? It's obtuse. Because we have one angle that's bigger than 90. Okay? And so sometimes it's kind of difficult to determine based on the way the picture is drawn. And I would say that that's probably one of those. Okay? Three sides here. Are any of those sides marked congruent? No. Okay? So can we determine if any of the sides are congruent? Not necessarily, right? So we would say this is a scalene. Okay? I also don't know anything about the angles, but what does it look like for all three angles? What kind of angles does it look like we have here? Acute. Okay. I think this one would be pretty easy to say that those are all less than 90. So it would be scalene acute. Okay, the next question says, can a right triangle be obtuse? If I have a right angle and I needed to form a triangle, can one of these other angles be an obtuse angle? No. How come?
Because if there's 180 that can go around the angles of the triangle, and you take 90, there's not enough left to make anything greater than 90.
That's exactly right. Okay. A triangle has a total of 180. And a right triangle means we already have a 90-degree angle here. And I still have two other angles to come up with. If one of them was acute, the other one would have to be acute. If one of them is obtuse, if this was 100, I'm already at 190. I'm already over the 180, right? And so 90 plus x plus y have to equal up to be 180. Those two cannot be obtuse, okay? So we would say no. If I had a right angle with an obtuse triangle, then there's no way that we could make it equal 180. Okay, it would already be bigger. Because let's just say that the first obtuse angle would be 91. So if I said that this angle here is 91 and this is 90, 90 and 91 is already 181, and we still have another angle to add in there, right? So impossible for that to happen. Okay, two formulas that we have to know for today. We're going to give it to you here in this box. We've seen these before. We've used them before. We've done a lot of work with them, especially the distance formula. These two formulas you got to know, okay? Distance formula and the slope formula are formulas that we're going to continue to pop up over and over again. So starting off with the distance formula. You got to be able to know it, okay? Early on, we gave you the distance formula when we use it, but from here on, I mean, we've used it so much, you should know that from here on out. Probably won't give it to you on every single test or quiz because we've used it so much. You need to know it. The slope formula, we always use m to represent slope. So the slope formula is y2 minus y1 over x2 minus x1. Not new formulas. We've used those in a lot of different situations before. And we're going to use them again today. So on the next couple of problems, we're going to talk about where that can come into play. Okay, on this first one here. You can put this onto a coordinate plane if you want to. Like if you wanted to get out a piece of graph paper and you wanted to plot it, but in most cases that's not going to help a whole lot because if I have a slanted side, then I can't just count. And so, you know, graphing it's not always going to be the end all be all of everything here. In some cases it might help, like if my line's vertical or horizontal, maybe that would help. Okay? It might help for your slope because then you could do rise over run instead of the slope formula. But the easiest way to do this, if I'm going to do sides, I got to do the distance formula. If I'm going to do the slope, then I got to do the slope formula. And we're going to talk about what that tells me here in just a second. Okay, so we're going to have to do this 3 times. We're going to do it for OP. We're going to do it for PQ. And we're going to do it for OQ. Okay, so OP, we're going to use the first 2 ordered pairs. 0, 0, negative 1, 2. So we're going to do x2 minus x1 squared. So we're going to do negative 1 minus 0 squared. y2 minus y1 squared would be 2 minus 0 squared. If I simplify this, negative 1 minus 0 is negative 1. If I square it, it would be positive 1. 2 minus 0 is 2. 2 squared is 4. This becomes the square root of 5. Okay, then we're going to do PQ. So we're going to do these 2 points. So we're going to start with 6 minus negative 1. Really watch your signs here. 6 minus negative 1 really becomes 6 plus 1. Three minus 2. 6 plus 1 is 7. 7 squared would be 49. 3 minus 2 is 1. 1 squared is 1. What we're trying to figure out here is what the length of these 3 sides are. We got a triangle, so we have 3 sides. So we still got to do OQ. OQ, we're going to do 0, 0, and we're going to do 6, 3. Now we're going to use the first and the last. So we're going to do 6 minus 0 squared plus 3 minus 0 squared. So this is 36 plus 9, which is 45. So my 3 lengths are radical 5, radical 50, and radical 45. Are any of those sides the same length? No. So what would we say? How would I identify this triangle?
Scaling.
Scalene. All three sides have a different length to them. Okay, so they're scalene. Okay, for slope, all we're looking for is are any of the sides perpendicular? Okay? How do we know if two sides are perpendicular? What does perpendicular mean once again? If two sides are perpendicular, what have they formed? A 90-degree angle. Okay? So if we have two sides that form a 90-degree angle, then we would have a right triangle. Okay? That's the only thing that slope's going to tell us here. Okay? So that's all we're going to try to decide here. Is it a right triangle or not? Okay? And we can't determine if it's anything else based on that. But we can determine right. So once again, we're going to do OP, PQ, OQ. We're going to find the slope of all three of those. So let's do OP first. 2 minus 0 over negative 1 minus 0. And then simplify it. Negative 2. Okay, PQ. We're going to use P and Q. So we're going to go 3 minus 2 over 6 minus negative 1, which is really 6 plus 1, which would be 1 over 7. Then the last one, we're going to use O and Q, 0, 0, and 6, 3. Make sure you put y's on top. So we're going to do 3 minus 0 over 6 minus 0. If two lines are perpendicular, how do we know? Based on their slope. Okay, opposites, and what else? One other thing. That would be the opposite. One's negative, one's positive.
Switched in opposites.
Okay, and they're also the reciprocal. They're also flipped. Okay, remember that little saying we used way back when we said flip the switch? We flip it over and we switch the sign. Okay, so are any of these two flipped and switched?
Actually, yeah.
Which ones? Which ones?
2 over negative 1 and 1.
These two, right? Because if I flip this one, it becomes 1 over 2. This one's positive, this one's negative. And so what I would say here is OP is perpendicular to OQ. There's that symbol for perpendicular again. So that means this is a right triangle. Okay. So I'm going to write this up here again. Flip the switch. We're looking for two slopes that we can flip it over and switch the sign. They have to be opposites. 1 over 7 would have to be negative 7 over 1. So that's not even close, right? But the other two, OP and OQ, it does work for. Okay, let's look at this one down here. Before we do this one, let's review the slope of a horizontal line. If I have a line that looks like this, it's horizontal. What's the slope of a horizontal line? 0. Okay. A vertical line, what's my slope? Undefined, yeah. No slope. Okay. And the reason we talk about that is because if I have a vertical line and a horizontal line, are they still perpendicular? Yeah. Okay. So those two would not flip the switch. Okay. And so we'll talk about that here on this problem. Okay, so let's do distance formula again. We're going to do AB, we're going to do BC, then we're going to do AC. And it doesn't matter what order you do them in, you just have to do all three. So this would be 3 minus 0 squared plus 3 minus 0 squared. So that would be 9 plus 9, which would be radical 18. Okay, BC. Negative 3 minus 3. 3 minus 3. Okay, what's negative 3 minus 3? Negative 6. And when I square negative 6, I get 36. So this would be 36 plus, and then 0 squared would be 0. The square root of 36 would just be 6. If it's a nice, perfect square, then we can take the square root of it. Okay, and then the last one, AC. Negative 3 minus 0 squared plus 3 minus 0 squared. We have two of them that are the same. The third one is 6. That one's not the same. Okay, so if we have two sides that are the same, isosceles. Okay, and then the last thing that we're going to look at is slope. And all we're looking for here is, do they form a right triangle or not? So once again, we're going to do AB, BC, and AC. Three minus 0 over 3 minus 0, which is 3 over 3, which is 1. Okay, BC. We're going to do 3 minus 3 over negative 3 minus 3. What happens when 0 is on top? It's 0, okay? What happens when 0 is on bottom? It's undefined, okay? There's a big difference between those two. If you're not sure which one's which, put it into the calculator. If you put 0 divided by negative 6, your calculator will give you 0. If you were to try to take negative 6 divided by 0, your calculator would say error, okay? It wouldn't let you do it, okay? So there's a big difference between 0 being on top or 0 being on bottom. And this time it's on top, so it's just 0. And then the last one, we're doing AC. So we're going to do 3 minus 0 over negative 3 minus 0. Okay. In order for this one to be perpendicular, I'd have to have one that's undefined. So there's no undefined with 0. What about 1 and negative 1? Are they perpendicular to one another? Yeah, because if I take 1 and flip it over, what do I get? Still would get 1, right? And if I do the opposite, it becomes a negative 1. So we're going to say AB is perpendicular to AC. So this is a right triangle. So we would say this is an isosceles right triangle. Okay. There's really no kind of shortcut to get there. If there was a shortcut, I would show you the shortcut. All right, we're back to big ideas today. Should be 5-1 day 1.